Structural patterns. Structural patterns deal with class and object composition. For example, the concept of inheritance allows us to compose interfaces and objects so that they can obtain new functionality. So, a structural, you meet you may you may think that it's a constructor pattern, but it more so deal with how objects or functions decompose in the system. So I'll expand on that later. For example, structural patterns provide the best methods and practices to organize classes and objects. Following are the JavaScript structural patterns that we will discuss in the next section. First, facade pattern. Second, the mixin pattern. Third, the decorator pattern. Fourth, flyweight. The facade pattern. When we put up a facade, we present an outward appearance to the world which may conceal a very different reality. So the thing I keep talking in the previous video, the hiding of implementation in a simple interface is the composition or the decomposition of objects and classes within our system. So it's how we organize depending on the design of our system. So for this, for example, the concept of the inheritance, it allows us to provide new functionality, but it doesn't tell us if we need to inherit in the first place, because like what we've mentioned, some programming language such as JavaScript support support classes through their built-in language. So in those cases, most cases, you don't actually build like an inheritance or classes in it. So those also kind of counterintuitively included in how we structure or how we composed or decompose our objects and classes, again depending on the design. So in this case, the built-in language feature which JavaScript already supports, which is the prototype. So for example, this inspired the name for the next pattern we'll review, the facade pattern. This pattern provides a convenient higher level interface to a larger body of code, hiding its true underlying complexity. So to expand on this, structural pattern provides the best method and practices to organize classes. So this is one of those methods. So think of it as simplifying the API presented to other developers, a quality that almost always improves usability. For example, here we have a client. This is the facade we show, or the interface we show, and this is the complex implementation. As you can see, the complex implementation is really could be a multiple modules that has a multiple methods and functions and a nested modules behind it. But you can see that because it's hiding in a facade. Facades are structural pattern that can often be seen in JavaScript libraries such as jQuery, where although one implementation may support methods with a wide range of behaviors, only a facade or limited abstraction of these methods is presented to the public for use. So a jQuery actually, for most people who don't use JavaScript, provides facade for its complex or usually for its complex features. So the language are designed for that, like facade structural pattern. So it uses highly this structural pattern method to provide its complex implementation under hood, or complex module, nested modules, and methods. These allow us to interact with the facade directly rather than the subsystem behind the scenes. So instead of like interacting with the actual submodule or module, it allows us to interact with the facade method. So this method, think about this as renaming these modules, this combination of modules and methods, to its own methods inside of this facade module that we keep discussing earlier. Whenever we use jQuery's $el.ess function or $el.animated methods, we're using a facade, the simpler public interface that let us avoid manually calling the many internal methods in jQuery core required to get some behavior working. So this simpler public interface of jQuery allow us to avoid manually calling that behavior or object or prototype created inside of this facade. This also circumvents the need to interact manually with DOM APIs and maintain state variables. So instead of you like interacting directly from your module to the actual DOM APIs of the browser to manipulate the HTML, which could lead to state leaks and unexpected behavior or crashes and a variable, undefined variable, etc., or any runtime error. You just need to contact this facade, and it allows you, or I don't want to say it abstract from complexity, but I want basically it allows you to like first there's a lot of benefits to it. It's not like one thing that allows you. So some of things that it allows is that you don't need to be aware of these complex modules within it, while at the same time it makes the code maintainable, and then it avoids state leaks, so it has a lot of benefits basically. The jQuery core methods should be considered intermediate abstractions. The more immediate burden to developer is that the DOM API and facades make the jQuery library so easy to use. So because of this, the danger is that it's so easy to use and it's so abstracted that people don't know the nuance on how it actually works. Therefore, they can misuse it. So to build on what we've learned, the facade patterns simplify a class interface and decouple the class from the code that uses it. These allow us to interact directly with subsystem in a way that can sometimes be less error prone than accessing the subsystem directly. So another thing that it is, or another way to describe it, is that it allows us, sometimes, most of the time, this is a good way to interact because it allows you to decouple, but also sometimes it's better to access the subsystem directly. Let's look at the pattern in action. This is an optimized code example, but here we're using a facade to simplify an interface for listening to events across browsers. So we do this by creating a common method that does the task of checking for the existence of features so that it can provide a safe and browser compatible solution. So basically this method check for all the features so that your app could run into different browser. So we simplify this interface for listening to events across multiple browsers. So here const add my event equal parameter l comma ev comma fn. So inside if l dot add event listener, so inside l dot add event listener parameter ev comma fn comma false, else if l dot attach event inside l dot attach event parameter on $ev comma fn, else l inside on $ev equal fn. In a similar manner, we're all familiar with jQuery's $document.ready function. This is another example of a facade where the rest of the world uses the limited interface exposed by $document.ready function, and the more complex implementation powering it is kept hidden from sight. Internally, this is powered by a method called bindReady, which is doing this. So function bindReady inside, so this will document.add event listener with the parameter dom content loaded string comma dom content loaded comma false closing. So this uses the handy event callback, and then window.event add event listener parameter load comma jQuery.ready parameter comma false, and then closing. So this is the method that we're talking about here. It could be the method in submodule, we don't know, but it doesn't matter, we can still use the interface. So in a similar manner, we're all familiar with jQuery's document, we'll just repeat. So facades don't just have to be used on their own. However, you can also integrate them with other pattern, such as the module pattern. So this facade, though we think of it like it's a separate concept, it's usually used with other patterns such as module pattern. So here, as we can see next, our instance of the module pattern contains a number of methods that have been privately defined. So a facade is then used to supply a much simpler API for accessing these methods. So here we have a private methods get, set, run, jump, and then we export the underscore private. So people just use underscore private that set and then with an argument val, as you can see, and then we export again actually. So this we create this like the base module, and then this kind of reference this. So it's useful to think at first it's inheritance, right? But it's not. So here index.js import module from /module.js, then it outputs current value 10 and running. So as you can see, we just use module.facade, and then we put the key value or the argument run true and then val 10, and then it will output the current value 10 and running. So in this example, calling module.facade function will trigger a set of private behavior within the module, but the users aren't concerned with this. We've made it much easier for them to consume a feature without worrying about implementation level details. The mix-in pattern. In traditional programming languages such as C++ and Lisp, mix-ins are classes that offer functionality that a subclass or a group of classes can easily inherit for function reuse. So in a C++ language, mix-in is actually not a pattern but a class. It offers that functionality that a subclass, or the one that inherits from it, or a group of subclass or a group of child that inherits from it can easily inherit for function reuse. So that's kind of like the abstract classes we're thinking when we talk about object-oriented programming. Subclassing We have already introduced the ES 2015 Plus features that allow us to extend a base or superclass. Actually, that's superclass. It calls superclass in those OOP and call the methods in the superclass. The child class that extends the superclass is known as a subclass. Subclassing refers to inheriting properties for a new object from a base or superclass object. A subclass can still define its methods, including those that override methods initially defined in the superclass. So, another thing is that you can override the method that was previously described, okay? Because people think that when they extend a class, that they need to automatically use the method in this class. So that's not actually how superclass and subclass work. So this is how the mixin pattern works. So the method in the subclass can invoke an overridden method in the superclass known as method chaining. Similarly, it can invoke the superclass constructor, which is known as constructor chaining. So another thing with mixin, it's just like with facade and module, it is not being used as a standalone. It's usually being used with other pattern, in this case the constructor pattern. So the superclass acting as a mixin pattern construct an object that will be that you could use or override as a base for your subclass. So to demonstrate subclassing, we first need a base class that can have a new instances of itself created. Let's model this around the concept of a person. So here is the superclass that can have a new instance of itself, or can can be inherited by a subclass. So these are actually this superclass is called person, and it has constructors. You can see constructor first name, inside this that first name equals first name, this that last name equals last, this that gender equals to male, then closing. So a new instance of person can then easily be created as follows, like const Clark equal new person with an argument Clark string comma Ken string. Next, we'll want to specify a new class that a subclass of the existing person class. Let's imagine we want to add distinct properties to distinguish a person from a superhero while inheriting the properties of the person superclass. So let's say a superhero still have this basic functional or methods of a person. So we will inherit this superhero subclass from as a person superclass. So here class superhero extends person constructor first name comma last name comma powers. So we create, as you can see guys, this is another pattern for extending a mixin and then using invoking a constructor pattern from that subclass. Since you use you basically extend the constructor pattern from you basically use the basic or rather the mixin or the basic you extend, let's say we extend the mixin and the constructor pattern from the superclass, and then in this subclass we also have a mixin and no, Um, Basically, as you can see, guys, let me just refine it. This is our superclass. So when you use this and then import this module to this, you're basically doing the mixing pattern, right? And then if this, you import this to another module, that's not a mixing pattern anymore because you don't have this like super class or base class. Okay, so the only way for you to have a mixing pattern is you have those super class technique. So here, as you can see, in this subclass that we inherit from superclass, we have a constructor pattern. But here we added another parameter. So this is another pattern. Whenever we're creating a subclass and we usually add our designated parameter. So inside we have super. So that's super argument parameter first name comma last name. So this invoke the super class constructor, and then this dot powers equal powers, then closing, then closing. So this super is a pattern that invokes the super class constructor, which is the person. So invoke that, it gets the property or the method of first name and last name here, not the gender. And then it added the power, this that power equal power, which is the parameter it added. So a new instance of superhero can be created as follows: const superman equal new superhero with an argument string Clark comma Kent comma square bracket string flight comma hit dash vision, then closing. Then next line console.log superman, inside is a superman object. Then it will outputs person attributes as well as power. So that's another pattern. Once you create that object, you can then use that object in the console or console.log that object to show the value that you argue in that new parameter. So objects of this type have attributes of the classes above in the chain. If you had set a default values in the person class, superhero could override any inherited values with values specific to its class. So if you like set like for example Garrett and then encomienda in this subclass could override that. Additional thing is that some of this method could not be used or like could be ignored in a subclass, as you can see in the gender. So that's another properties of mixin. So mixins in JavaScript, we can look at inheriting from mixins to collect functionality through extension. Fly with sharing data. So we have more to go. Let's just continue with that in the next video.